Covalent bonding.
In covalent bonding, there is no transfer of electrons between the atoms. Instead, there is a sharing of a pair of electrons between the two reacting atoms so that both can attain stability. That is octet or duplet configuration. There are two types of covalent bonding. That is ordinary covalent bonding and coordinate covalent bonding. For ordinary covalent bonding, each reacting atom contributes one or more electrons each to be shared by the atom. Shared pair refers to the pair of electrons shared during bonding. An example of ordinary covalent bond is found in the formation of hydrogen molecules.
Hydrogen is the simplest element. Two atoms approach to share their electrons.
Two atoms of hydrogen are covalently bonded to form the hydrogen molecule. Let's draw the structure of hydrogen. Now, in the normal sense, this is hydrogen, this is hydrogen. They both require one electron to be stable. They will tend to combine together and then share their electrons. So instead of giving out electron, as in electrovalent bonding or ionic bonding, in this case, they turn up to share the electrons among themselves. Should this hydrogen give out the one electron, there will be no electron left in this. So this one will be unstable. It will not survive, making this one stable. Now, they all have to obey the duplex rule. So it is best for them to bond. So that is how the hydrogen molecule is formed.
Water molecule is polar. Oxygen pulls electrons, becoming negative, while hydrogen becomes positive.
In the formation of the water molecule, two atoms of the hydrogen and then one atom of oxygen is bonded. Let's draw the structures of the elements present in the water molecule. Let's first of all draw the structure of the oxygen. Now, hydrogen has just one electron in the shell, whereas oxygen has 6 valence electrons, so 6 electrons in the outermost shell. Now, oxygen needs 2 electrons to be stable, whereas hydrogen needs 1. This hydrogen also needs 1. So, should hydrogen give out this electron, there will be no electron left in this shell, so it won't survive. So, this hydrogen give out the electron, that one will also not survive. So, what it tends to do is that they end up sharing the electrons. So this electron will come and bond here and then share with that of the oxygen. Then this one will also bond here to share with that of the oxygen. So this is what happens. They end up sharing the electrons. So there will be 2 electrons here in the hydrogen shell, and then 2 electrons here in the shell of hydrogen, and then there will be 8 electrons in the outermost shell of that of oxygen. So this is how water is formed. Coordinate covalent bonding, also known as dative covalent bonding. The difference between the ordinary covalent bonding and the coordinate covalent bonding is that in ordinary covalent bonding, there is the sharing of electrons among 2 atoms. But with coordinate covalent bonding, only one atom donates the electrons to be shared. The electron shared is called the lone pair. The following are examples of compounds that exhibit dative covalent bonding. Let's look at the formation of ammonium. Ammonium has nitrogen atom and then 4 atoms of hydrogen. Let's draw the structures of the elements present in this ammonium. So nitrogen has 5 electrons in the outermost shell. So it needs 3 more to be stable, whereas hydrogen has only 1. Now, nitrogen is being bonded to 4 atoms of hydrogen. Now, in this case, for both of them to be stable, this hydrogen will come and bond here. It will combine to this. Then, this hydrogen, let's say, will combine with this. Then, this hydrogen will combine with this. Now, nitrogen will be stable. It will have 8 electrons in the outermost shell. Whereas these 3 hydrogens will also be stable, leaving 1 hydrogen behind. Let's also not forget that there is a lone pair of electron here. So there are 2 electrons left. They are not bonded to any of the hydrogen, so they are lone pair. And there is 1 hydrogen here. In this case, nitrogen is already stable and does not need any other electron to be stable, but hydrogen is unstable. So hydrogen will then come and bond here in order to be stable. So hydrogen will be receiving 1 electron to be stable, but nitrogen does not need anything. So in this case, hydrogen will be bonded with a lone pair of electron, and it will be receiving 1 electron, whereas it won't give an electron. So that is dative covalent bonding. Lewis dot or dash formula. It is simply a formula using dots to represent valence electrons. A bonding pair is a pair of valence electrons shared between 2 atoms during a bonding process. A lone pair is a pair of valence electrons that is not shared between 2 atoms during a bonding process. You should note that bonding pairs are represented by dashes, while lone pairs are represented by dots. So, for hydrogen molecule, we know that it contains 2 atoms of hydrogen. So 2 atoms of hydrogen. There is only 1 electron in the shell of hydrogen. And with Lewis structure, we deal basically with the valence electrons. That is the number of electrons in the outermost shell. So first of all, let's draw the shell structure for hydrogen. Now, if they are to bond, let's not forget that hydrogen, it's not a metal, and bonding between non-metals are covalent bonds. They will end up sharing electrons. So if we are to represent this using Lewis formula, what we do is that in this case we are not drawing the structures, we are just using the chemical symbols. So for the chemical symbol for hydrogen is H. So in this case we have our hydrogen, which is going to bond with another hydrogen. Now for the valence electron, hydrogen has 1 electron, so this hydrogen has 1 electron. This hydrogen also has 1 electron. Now, as they bond, you realize that this will bond with this covalently. So, they will share electrons. As they share electrons, they will become bonded pair electrons. Now, we also said that bonded pair electrons are represented by dash. So, the moment you realize these are bonded pairs, you rewrite the entire thing as your first hydrogen, which will bond another hydrogen. Let's answer option B. Now, oxygen molecule. For oxygen molecule, we know that it contains 2 atoms of oxygen. So let's use the chemical symbols for oxygen. So oxygen plus another oxygen. Now, how many valence electrons does oxygen have? Now, oxygen is atomic number 8. So the inner shell will take 2, whereas the outer shell will take 6. So the valence electron is 6 electrons. Let's distribute them. 1, 2, 3, 4, 5. Then let's say 6. 1, 2, 3, 4, 5, 6. This will bond with this, and this will also bond with this, leaving the others. So there will be double bonding. So we have 2 bonding pairs. So 2 bonding pairs. Now the electrons that are not bonded are the lone pairs. And how many do we have? We have 1, 2, 3, 4. So we have 4 lone pairs. So let's answer option D. For water formation, water contains 2 atoms of hydrogen and an atom of oxygen. Now hydrogen has 1 electron. So 2 times the hydrogen will give you 2 electrons. Then oxygen is atomic number 8, so has 8 electrons. Since we are using the valence electrons, so we want the electrons to the outermost shell, and that will be 6. So 6 valence electrons. So that means in total we'll be having 8 valence electrons